Make sure it's recording. Yes, it is. All right, so this is continuing analyzing exponential functions. This is 2.5.1, part 2. Before we get into the next step, so yesterday was pretty much dealing with the growth decay factor. The growth decay factor is part of the exponential function. It's right in here. Everything we did yesterday was taking this value, whatever it is. Remember, we subtracted 1 to find the growth decay rate, and then we changed it to a percentage. Okay, so that's what we're going to get to on this board. Before we start there, we just have to review the power of a power property. Okay, we're going to have to use this as one of the segments. I want to review this skill pretty quick. Oh, you don't want to see that. You don't need that. 3 to the 4th power squared. Okay, if you forget the rule for this, you can always expand it. You can use the expand method. We did this a lot. 3 to the 4th power is 3 times 3 times 3 times 3. Okay, but it's squared, so I know it's that quantity times itself. So we have 4 3s. That's 3 to the 4th, but it's squared, so I have it over here. How many 3s do I have? 8. So it's 3 to the 8th power. Now, what is our shortcut that I'm sure many of you can see to go right from 3 to the 4th squared down to 3 to the 8th? What did we do? Good. We just multiplied these. So we multiplied them in order to go right to our answer. So just look at these examples. I think we can do these ones pretty quick. If I have 5 squared to the 3rd power, I end up with the base 5 stays. What's my exponent now? 6, right? And for now, you can keep that. You could multiply that out and get something. But you don't have to. We're just reviewing. How about 10 to the 7th squared? 10 to the 14. All right, Jonathan. All right, so this is the next step. Now we're just dealing with variables that are going to be in the exponents. So I have 3 on the inside. Really, that's just 3 to the 1st power. But it's 2t on the outside. Now the reason we're trying to figure out how to pretty much just get the variable alone as the exponent is because the exponential function just has t on the outside. So we're really just rearranging this so that my exponent on the outside is just t. Okay. So what do I need to get rid of for this example in order for the exponent just to be t? 2. I need to get that 2 out of there, right? What did we learn up here when I have an exponent? When I apply it to the inside, what do I just do? Multiply. I multiply. So what I'm going to do here is, just looking at the 2, I'm going to multiply it in, and I put 3 to the 1st power just because we can remember there is an exponent there. It's just to the 1st power. Okay. So what is 2 times 1? 2. V squared now is on the inside of the parentheses. T is on the outside. All right. So all we did there was remember the power of a power property. When we have power to a power, we can multiply it in. So in this case, I just multiplied the 2 into the inside, leaving the t on the outside. That's what we want to get to. Can I simplify in the parentheses? What's going to happen there? What's going to happen? 3 squared. 19. Next example, in the back might be hard to see, but it's 2 raised to the 2t. So what am I going to do with the exponent here just to get t alone by itself? Jason, what do you think?
2 squared and then t.
Good. So you're first thinking, conceptualize it's 2. Got it. There you go. That's the new slang for that step. All right. What's 2 squared?
4.
So I end up with 4t. How are we feeling about doing this step right here? Right? Honestly, this is the crux. This is like the little ingredient that's new. Okay? So we've already learned this rule, and maybe that's why it comes pretty quick for us here. All you need to think is, I can multiply the exponent if I like. This is 2t, so I multiply in 2 times 1, putting the squared value on the inside, and then I just evaluate, or compute out what 3 squared is, 19. Okay. How do we feel about this first part? Thumbs up, sideways, or down? What do you think? I only get some people lifting. Come on, everybody, tell me. Thank you. All right, we're good. We're good. All right, so this is new. This is the new part over here. And I want you to think of these root formulas. Remember we had the root formulas for parabolas, right? We had the root formula for our absolute values, right? So here, this is the root formula for the exponential function. With this, tomorrow when we play around with Desmos, we'd be able to put in the exponential function, our root formula, and then we'd have some sliders for a and b, and we can move around those values. So this is really key. We actually want to have, when we review for the midterm, we'll have all our root formulas together because it's almost like a map. Okay. Think of a map. If you visited a new city and you saw the map once, you know, you're at the hotel, you look at the map, would you leave the map in the hotel? No. I mean, why? Bring it with you because it's new. Okay, so think of this as our map. This is our map, and it tells us where everything is located. So f of t, the function, remember function notation, is just f of t, the function of time, is equal to a times b raised to the t. A value every single time is the initial value. That's what we're starting with. And b is our growth decay factor. This is what we did yesterday. So again, remember yesterday this was some decimal. If it was 0.34, we took 0.34 minus 1. We then figured out if it was growth or decay and changed it to a percent. So a lot of what we have to do for homework and classwork is, again, looking at the growth decay factor. The thing is, we have to have it in this form. We have to have it in this form. We can't have a 2t out here. We can't have an 8t. It just has to be a t exponent. That's it. So the first step, rearrange to get into the f of t times ab to the t power. So we need to first rearrange it. And we're going to look at some practice problems on this side. Whoa. Let me try this. People at home are like, please stop. Please. That'll work. Kinda. That's good enough. All right, so let's look at this example problem up here. For the homework classwork, you're going to have to find, the book asks you to find the growth decay percent, and if it is growth or decay. I'm adding these two things here because one's really easy to find and one takes a little bit of plugging in, some evaluation. But they're going to come really quick because look here, what's the initial value? Let's look at our map. Where do we find the initial value? A. What is the A value in this case? 10. So one part of the problem, there's 4 parts in each problem. One part is going to be really quick right off the bat. Initial value is 10. Okay, then we need to look at, do we have it in our standard form? Do we or don't we? And if we don't, what is different with this practice problem in the standard form? What's different? This is just looking at it and seeing what is different than the formula here. We have an A value, that's just, yeah, William.
Is it 2 before the t? Good.
This is a 2t, right? We need it to be in the exponential function form, in the root form, before we can do any of our taking out of information. So we need to get it so that it's just t on the outside. So what should I do? What should I do with this 2 right here in order to make this in our form we want? What should I do? We were playing around with it in the beginning. Yeah, Wayne.
We could imagine the 0.4 in the parentheses to the power of 1.
Good. Okay, so first think of this. Okay, it has an exponent of 1. Then what? Then what should we do? I don't know. Oh, yeah.
Multiply the 2 and 1.
Okay. I thought you were telling me the answer somehow. Like 2. Okay. We're going to multiply in that 2. We end up with f of t is equal to 10.4 squared raised to the t power. Okay. Everybody see what I did there? Okay. Let's go ahead and take it a step further. Let's make it 0.16 raised to the t. All I did was evaluate or compute that 0.4 squared. Okay. All right. So do we have it in the standard form now? We do, right? So I'm going to go ahead and box that out. That's my new formula for the standard form. In the standard form, we're ready to take out the growth decay factor. Now we're ready to plug in our t value when we get to that. So let's look. Thinking from yesterday, you were given the growth decay factor yesterday. I just gave that to you as a decimal. Where do we look, or what is the growth decay factor in this? What is that initial amount that we're dealing with? Good, it's right here, right? So what I'm going to do is similar to yesterday. I'm going to take 0.16, subtract 1, and I get negative 0.84. Remember, this was, now we have the growth decay rate, but we need the growth decay percentage. But before we do that, let's look. What is this? Is it growth or is it decay?
Decay.
How do you know?
It's negative.
Negative. So we had, how did I do this again? It's decay because it's negative. Little smirk down. Okay. So decay is negative, so it is going down. We know then it's decay. That's another part of the problem you have to do. It's decay. Now, I have 0.84. I know it's decay, so I can forget about that negative as far as in my answer goes, because I know it's decay. I don't need to be redundant with that. But what's 0.84 as a percent?
84%.
How do you know? You move it.
The decimal because it's to the right.
Boom, boom. Okay, so we get 84%. All right. So a lot of this looks familiar, really. The only thing we've done different so far is we know the initial value, and we had to manipulate it a little bit to get to where we can pull that out. Okay. What's left? Yeah, that's all we have to do. The last bit, to find the value when t is equal to 3, all we have to do for that is take our modified formula, which it would work from the top part here, but then you have to have a bigger exponent to deal with. So I say, let's just take our standard form right here that we placed it in, and we'll go f of 3. See what I did there? All I did was plug in 3 for t. All right, let's see. Everyone will use a calculator for parts of this. You don't know your 0.16s to the third power. What kind of students are you? Just kidding. 0.004096. I suggest keeping the decimal pretty long when you're within the problem. Don't round very much within the problem. The final answer, we'll do it to the hundredths place. So just like money, it's going to be 2 decimal places. All right. It's times 10, so I know I really am just moving that decimal over 1 time. So this is a pretty big decay. We started at 10, and after 3 time periods, we end up with 0.04. We'll go ahead and put 1. That's pretty significant right there. Those are the 4 things we have to find for each problem. Again, remember, in the classwork homework, the instructions for these problems do not also ask you to do the initial value and value at t is equal to 3. That's what you have to do in addition. Okay. All right, we got one more. This is going to go even quicker, I think.
Yeah, somebody there.
All right. Hey, Daniel, what's the initial value?
The initial value? It's 77.
Oh, yeah. All right, do we have it in standard form? Do we have it in the standard form yet? No, what do we need to do? What do we need to change in order to get the t on its own on the outside? Right. This is the only kind of hard part if we're not familiar with the power of power property. This is why I started with that. It's because we're going to put the 8 on the inside here. And we haven't changed it. We've just used that power of a power property to modify it. And we're getting closer. Let's do 1.08 raised to the 8th. Oh, yeah. 0.851 t. All right. This is my new standard form. I know it's standard form because I just have my exponent as a t. Okay. So we modified it. Now we're ready to go. What do we need to do in order to find our percentage growth decay and if it's growth or decay? All right. We're going to take this. 1.851. We're subtracting 1 minus 1. 0.851. Okay. Growth or decay? Is this going to be growth or decay? Growth because it is positive. Because it's positive. I could do another piece. It's a weird smirk. Something's wrong with that guy. All right, so we know it's growth. Let's go ahead and represent this as a percentage. What's this as a percent? 85. Good. Good. We move it 2 over, and then we end up with 85.1%. 85.1%. Last step, everything we've done so far, except the initial value, is what we did yesterday. We know we have to get it here into the initial, the root form, and then we can pull everything out. We have the t on the outside. We knew that was right. So now I want to take this and do f of 3. Let's see what we get. Raised to the 3rd. Time, I'm just going to do it all the way up. We get 488.27. 488.27. So you started with 77. You had a 85% growth, so you end up with 488.27. So that's like Ethereum stock between like April and July, because that's really meaningful to all of you. All right, thumbs up, sideways, or down for this one. What do you think? This far? You're still riding. Some of you are riding, but I see a lot of thumbs up. Great. All right, we have a challenge for our subscribe message to the can't even say it. All right, so we're going to start our subscribe really low, and we're going to go all the way to as loud as we can. Are you ready? Subscribe on 1, 2, 3. Subscribe. I think that flopped. All right, subscribe on 3 loud. 1, 2, 3. Subscribe. Thank you for humoring my ambition to get YouTube advertising.